All right, thanks everyone for coming today. I realize this is up against Brent and Greg, so everyone here, thank you. I'm sure the room was completely full, and I'm okay being your second choice. That's fine. Before I get started, let me just kind of introduce myself and what I do at Facebook. I've been at Facebook for a long time now, and I'm on a team called Web Foundation. Our team's responsibility is kind of to be first responders for major site outages, and then when there's not an outage of some kind, to actually be working on longer-term reliability efforts. So the topics in this talk are near and dear to my heart. It's what I do day in and day out at my time at Facebook. So we'll be covering a few topics today. One, just kind of a quick overview of incident management in general. This varies a lot company by company, depending on size and things you've encountered. So we'll go through a few things there. We'll talk about Facebook and the challenges it's had over time, where we landed at today, and then like a few of the kind of key takeaways I think that are super important, right? So first, the goals of incident management. Before we do that, let's try to wake everyone up. I want some questions for you, and I want you to raise your hands, okay? How many of you have been a responder to some kind of outage at your company? All right, just about every hand, and other people are, I can't believe it. You'll get one soon, don't worry. All right, how many of you have caused an outage? All right, that's okay. There's no shame in that, okay? How many of you have had feelings about an outage, maybe that you caused or didn't cause? It happened, and it just made you feel something at someone. All right. So there's a lot of feelings involved in managing incidents and outages. That's kind of interesting. So to manage these types of incidents, you want process, right? When you have some kind of outage, your first primary goal is really to mitigate, right? It's not necessarily to solve it, but it's just like make the problem stop happening. So that might be solving whatever the problem was. It might be working around it. Like if a data center caught fire, you might just kind of have to migrate to another region. Or it might be, flipping the config back that just took down the site. One of the things to keep in mind during these incidents is like you don't want to be distracted too much by how bad the problem necessarily is. Like you don't want someone breathing over your shoulder, everything's down, when's it back? Everything's down, when's it back? You just want to focus on actually bringing it back. But this can be difficult. This is what process is for, is to help keep us focused on the primary goals of the moment. Often mitigating is actually different than the underlying problem, but when the breakages happen, you really do need to focus on like how do we quickly bring things back to a usable state. And this requires managing the humans, right? The human aspects. People are under stress. Things are going on. You want to have calmness. You want to have focus. And it can be pretty easy for a situation to evolve into chaos without some kind of structure or without some kind of process. So even though process can sometimes be a four-letter word, it is important to have it when you need it at key moments. And there are different kinds of outages that may occur. So one class are routine outages, right? These are the things that you might encounter on a fairly regular basis, a reasonable number of times per year, per month, hopefully not. This could be human error, config or code goes out that shouldn't. It could be mismatched expectations between two systems. Someone launches something, it changes an API in a subtle way, and all of a sudden, orders can't be placed anymore, and someone has to try to figure out exactly why. It can also be automation run amok, right? Who hasn't made a script that was going to do something cool or a query that was going to fix some data in a database and it, updated the wrong rows, or it took down the wrong servers or something like that. That definitely can happen. And does happen. Or it can be systems being overloaded. Maybe you were on the front page of Hacker News. Yeah, all right. It's our breakout moment, and your servers break down, right? That can happen too. Or an internal system goes amok. Again, overload. These are all the types of things that you'll encounter that you might have a reasonable playbook for. There are also unplanned events, things that you might not necessarily be able to account for. The most common is probably some kind of random fiber cut or issue with a facility. Someone with a backhoe comes along and suddenly your data center is without power or fiber. That can take a little while to recover from. Sometimes there's not too much you can do. Also, as this beautiful picture shows, hurricanes, right? The eastern seaboard of the United States, the southern coast, has a lot of fiber running through it. Also, lots of points of presence, lots of data centers in this area. Virginia gets hit by hurricanes every once in a while. That can happen. Earthquakes here on the West Coast, all sorts of other natural disasters. There's another kind of unexplained or unpredictable event, something like an SSL cert expiring. Who's had that happen? All right? And you would think, well, it's expiring. It's not an unplanned event. It's not unpredictable, but it happens, so it was unpredictable. These kinds of things happen. They're a little bit of a curveball, but again, there's maybe something in them that you can kind of at least think about. My favorite kind of outage, though, is a black swan failure. This is a fairly standard terminology. It has somewhat of a definition. It means an event that was a surprise, that had a really bad effect, and in hindsight, you're like, oh, we could have prevented that. right? This is kind of the high-level definition, but these are like the most interesting incidents in my mind. They often require multiple things to fail. If you ever read anything about like why an airplane crashes, it's usually because this failed and this failed and this failed, right? It's the sequence of failing events, the multiple systems that have to go out to create a really, really bad and scary outage. A number of these happen to infrastructure across the United States. Sometimes it's the physical infrastructure, sometimes it's the technological infrastructure, and usually it gets written up, and these are the kind of interesting ones. They're also, when you're dealing with these, the hardest to manage, because nobody really knows what's going on at first. Nobody really understands how to get out of this state, but you know it's really, really bad, and you have a lot of people trying to help. But they're also, once they're over, they're the most educational, because you learn like, oh, these were the 3 things that had to fail, and maybe they reveal some kind of deeper problem that if you fix that, you take care of the odd occurrence that was a black swan and maybe many other kinds of events. So while we have a number of different kinds of failures and classes that we can like bucketize in our brains, it's also important to think about how bad the problem is. Typically, systems will have some kind of severity level. Facebook calls, by the way, these incidents just SEVs, or for side event. But you can, whatever you call it, like you want some classification. It can be colors, red, yellow, green, or numeric levels. And Facebook uses numeric levels. They range from 4 all the way to 0, with 0 being the worst. Most are 1, 2, or 3. The key idea here is you want something that's a simple way to label incidents so that you know exactly what scale the problem is and maybe how to scale your response. Again, like whatever system you use doesn't matter too much, but having this in mind is important. So Facebook's incident management is kind of shaped over Facebook, the company. So key things about Facebook is, even today, we emphasize small teams. We like a bottoms-up decision-making in general, and we have a large amount of individual autonomy and team autonomy, and people move around between teams frequently. Despite this, we're at around 40,000 employees, so that's a lot of teams. You can kind of imagine how that comes together. And many of the challenges we have, just day-to-day, but particularly in incident management, come from getting teams and people to coordinate together. The biggest technical challenges we've had over many years really has been scaling. Technical scaling and people scaling. So Facebook was like founded in 2004 or so. And like initially it scaled by like having a database for a university. Harvard had a database. Stanford had a database. It worked great. Your database was the same machine as your web server, which was the same machine as your Memcache server, which is like running in a dorm room somewhere. Scaled great, right? It was very simple. Everything kind of worked. But of course, people wanted to use it. More and more people wanted to use it. It eventually got opened up to the public. And this scaling model doesn't work, right? You have to evolve your infrastructure and change it over time. So this growth and scaling has been a perpetual challenge for the company. There were many, many times where it was unclear exactly how to get 3 or 6 or 12 months into the future of scaling at the rate it was going, either from feature additions or just organic user growth. And today, around like 2.4 million or billion people are using the site a month, and almost 1.6 billion a day. That's a lot of people, so you can't obviously have just everyone on a single database. So this scaling was often like almost an existential threat, but there were external existential threats as well. Like look at the last 15 years of the industry. There have been lots of challenges, be it competitors or shifts in the industry from like desktop to mobile. Like all of these things are coming at any given time that challenge the infrastructure and engineering process. But more importantly, through all of this, we wanted to have our engineers empowered by an infrastructure that could scale, and that sometimes that meant that infrastructure was growing very quickly, and we had to have ways to handle the incidents that came up. One of the key places where incidents come from are complexity. Anytime you scale or grow something, it becomes more complex. Anytime something becomes more complex, it becomes harder to reason about. You can have 3 very simple systems that when they start interacting together actually have some very complex emergent behavior that you can't even necessarily predict. Scale that to thousands of machines and servers and engineers working on a system, and it becomes very complex. I mean, we went from basically servers in a dorm room to building our own data centers to handle some of this scale. You can imagine complexity that can sneak up in there. The emergence of this complexity presents lots of challenges, but one of the key challenges are with people. The knowledge, like why something was built, sometimes gets lost, or how it was built a certain way, or how it rolled out, or how it changed. This can actually get lost over time, and while you pass it down verbally, you want to try to write it down, but it's really hard. Like imagine if like half the people on your team left. It would be hard to understand how and why things are the way they are. So this is just a different kind of the scaling challenges we've had. So this brings us to like some key cultural things Facebook has done to combat this. One of them is that teaching and learning are super, super important. In a lot of ways, we kind of view like we're up against a challenge, right? The challenge of scale, the challenge of complexity. And we have a very open culture and open communication. You know, you can basically just go ask anyone any question, like why is it this way? And maybe someone knows. If you're lucky, someone knows. Otherwise, maybe they know who knows. Otherwise, hopefully you just have to go figure it out. And we really treat our incidents as learning experiences. We have built entire process around incidents. This is kind of coming back to the Blameless theme. In fact, we teach how our incident management system works in the second week at Facebook. When you first join, you go through a process called boot camp. It's like 6 weeks of like learning how version control and PHP and hack and HHVM and all these kinds of core things work. But during week 2, you're taught about site reliability and incident management. And one of the key things we really, really talk about there is how important it is to be blameless in the way we think about our incidents. You're not at fault for causing a problem. And this actually kind of gets to an unstated cultural norm. We actually really encourage people to ask for help. Like, there's humility in asking for help, and we understand that and accept it because we've all been there, and we're often facing problems we don't know the answers for. In fact, it's a worrying sign for people who don't ask for help. This is actually, one of the things we watch for is like if someone's struggling and not like saying, hey, I need a little bit of help here, that can be a concern. But one of the things we also emphasize is we don't count the number of incidents. We don't go look at Q3 and say like, hey, we had 50 major incidents, but in Q4 we had 60, so woo, yes. Everybody gets a great performance rating. We don't do that. We do track metrics around these things, but we never want to incentivize underreporting. Because if you don't report and you don't talk about incidents, you don't learn and grow from them. So what kind of system have we actually built? Well, at small companies, and this is true early at Facebook, you'll tend to know who to bring in to solve a problem. Like if it's a database problem, you've got like 2 people who know how the databases work, so you're probably going to want to get both of them, right? Or if it's a web server, a cache server, there's a relatively small number of people you need to loop in. They're probably all in one building, right? And like people fill in incident management roles organically. So during incidents, you've probably experienced them, there'll be someone who's trying to like kind of keep everything in order. There'll be someone who's actually trying to like make a change to a server. There'll be different roles that have evolved either organically or through the process you've defined. But when things are smaller, like and there are fewer people, it's just easier to understand who you should bring in. Maybe things like email and Slack or IRC just work, and that's all you need, right? You just send out an email to the mailing list saying, oh, we've got a problem, and everybody shows up and solves a problem. And it can be easier to mitigate because systems are smaller, and it can be easier to stay focused because fewer people are involved. But things have to scale. Things get harder as systems grow. Big incidents need more structured leadership and guidance to manage the chaos. As you have more and more people get involved, if everyone rolls up to a big incident and says, hey, what's going on? How can I help? That can actually be disruptive to the people doing the work. So you need to start structuring the communication. You need to know who to involve. Sometimes you might know the team to involve, but not the person. Sometimes you might not even know the team exactly because your database team that was 2 people 3 years ago is now 3 different teams, one for operations, one for the systems themselves, and one team actually working inside the core of the database. And is this problem at which level there? You don't know. So sometimes you need to know like these details of how even a company is structured. At Facebook, we put this expertise in a set of people called IMOCs, or incident managers on call. They're effectively people who understand a lot of our infrastructure, who've seen lots of outages, who've gone through them, who've coached people through them, and have dealt with situations as they came up. And we, in fact, scaled this. So it's no longer just one set of IMOCs for the company, but now, as the company's grown, there might be an IMOC for all of our advertising systems, or an IMOC for all of our database systems. And so we've scaled it out in that way, too, and tried to create almost like a recursive structure of the right people to go to so you know who to talk to. But even that, you can sometimes hit scaling limits. Eventually, email will hit some point where it's no longer effective. You don't want to email everyone at the company that there's a problem. There are some simple tools you can use. Like I think it's a pretty good idea to be using something like Google Doc templates or Quips or something like that. When you're like walking through a complex incident and you're trying to construct timelines, you really want to keep a record. At Facebook, we've built a tool for this, or at least for some of this. So there's a screenshot here. It's kind of fuzzy. I'll zoom in here onto a second. But we like to build tools. It's one of the things we do. We build internal tools. But this tool actually has some interesting properties. So this is what we call Sev Manager, Site Event Manager. It's a tool that's built to basically make it easy to surface what's going on and what the state of incidents are. Because we will track incidents very openly, and incidents might be very small. Now this is a terrible incident. Someone lost their slides for their LISA talk. This is a really big issue. So zooming in a little bit, you can see some of the fields here, like when it started, when it happened, when we realized it was. There's some tags, like, oh no, this is a data loss sev involving a presentation. We discovered it through employee reports instead of, say, alarms or user reports. So there's a lot of useful metadata we found here over the time. There's also a list of people you might want help from, like primary on calls, some of those IMOC roles I mentioned. But the nice thing about this tool is, since we've centralized in one place, lots of people can use the tools for, say, setting notifications. Like anytime a sev gets opened, I want my phone to make a noise. Right? That's something useful for my team when we watch over the site's reliability. We want to kind of have an idea what's going on, because something that starts small might turn into something big. This has an interesting kind of flip side to it, and it invites people to come help. Right? Even if you're no longer, say, an expert in databases, you might have kept your notifications for database issues to help out when there's a problem. And in fact, we see this play out frequently. Since we are so open about these incidents and we're inviting of people to help and to be involved, and we're not really playing a shame game or a blame game with them, people will show up. And so this tool makes it very easy to summon help. It makes it very open. Promotes like really effectively a culture of lending a hand, which is really important when you're dealing with serious site issues. Also, we encourage people to like pick those levels. Like in this case, it was clearly a Sev 1. This is a really big problem, right? But maybe it actually turned out to be a Sev 3, or maybe it turns out the slides weren't lost after all. They were just in a different Dropbox folder. Wow, that's good. False alarm. That's totally okay. We don't hold, we don't like go yell at someone afterwards or have a crucial conversation with them about like, oh, why did you file this Sev? Like, we really want people to be empowered to notice problems and to flag them. But our process has evolved over time, and even now, we've faced some recent evolution. So we've built these tools, but what we've discovered is the evolution tends to come in fits and bursts. And this is true of most infrastructure, right? You will get to a point where you're kind of able to make do with the system you have, and you can kind of push it, and then you're like, nope, we need to go invest in tools, and it swings back. And it's like really great, it's overkill for a while, and that keeps happening. And this is true of processes as well. You reevaluate it, you pull it back. This kind of iterative evolution is actually a really good model for incident management in general. For instance, those 5 Sev levels I mentioned earlier, like that Sev 0 one is relatively new. Just because failures of a company that's as large as we are, that affect as many different systems, are different today than they were 8-10 years ago. It's a different kind of all hands on deck when you're building hardware and not just software anymore. We've also have a new process for these major Sevs. We have a good review system, but we actually, for the really complex systems, those black swan failures where it's like still like mysterious why it happened, and like there are rumors or like suspicions as you're trying to understand it, like we go through a forensics process. It's like a very detailed understanding, because we want to make sure if we're going to have an outage that's bad, we're going to learn as much from it as possible. And this means like casting a light on every little corner, every shadow, so that you can best understand exactly what caused this issue and what you can learn from it. And then we will actually re-review these incidents so that 6 months afterwards we'll come back and say, hey, could this happen again today? What did we do last time to make it better? What did we learn from it? Again, re-emphasizing like these are good incidents to have. Like you don't want to have them, but when you do, that's fine. You can get a lot of positive from it. Like never pass up an opportunity to use a crisis for something good, right? Because you've already been through it. You may as well get some mileage from it. So where we're at today. Like I said, incident management training begins in boot camp. It's something we expect every Facebook engineer to be familiar with. We try to use the same process for many different kinds of issues. So we use Sevs for site issues, we use it for internal tool issues, we use it for product issues, we use it for issues in our data centers, for IT issues, for security, privacy. We try to use the same set of tools, again, because like we have iterated on them and honed them over time, and we don't want engineers to have to learn a bunch of different processes or have to know where to go to find out, hey, my Facebook's not loading, what's going on, right? You don't want to have to go to 3 different tools to try to understand that. Typically, Sevs will go through a fairly similar flow. You'll detect it, you'll file the Sev, people will come up and show up, you'll figure out how to mitigate it, you'll go through a review phase, and then that review will maybe find some follow-ups to prevent it from happening again. But a lot of what we do today focuses on the communication and awareness of Sevs. So you want to make sure that the right people know very quickly there's a problem, and that the right people are then pulled in to know how to help and contribute. Today we use IRC and Messenger. Like Facebook has always had IRC, but in the past several years there's Messenger, and we've launched Workplace, which is based on Messenger. But it does raise the problem when you're using your platform to help manage incidents on your platform, and that happens to be the system that's compromised. You kind of have this snake eating its tail problem. So we kind of have backups for that. But we try to make use of the best tools we have and to evolve and iterate on those. and then fall back to IRC. This process culminates in what we call main Sev review. So every week, we have this very large meeting where we talk about the most interesting Sevs from the past few weeks. This is a scalable review process, so while we do it at the company level, at a meeting full of very tenured engineers who've been around and seen lots of things, VPs, directors, all sorts of leaders in the company, we also do this at smaller levels throughout the company. Again, back to that model of, the company is large, there are different areas, and we need to make sure we give good review to all the technical challenges we faced. But we discuss the incidents. We go through a process. We have a little acronym for this process. It's called DERP. D-E-R-P. So we talk about the detection, how do we find out about the incident? E for escalation, how quickly did we bring the right people involved? Did alarms fire quickly enough? Did we get people on board? Resolution or remediation, okay, what did we do to recover? How did we get everything back to normal, or at least to the point where it was mitigated? And then finally, prevention, what's in place to make sure this never happens again? And in this review, we will go through the incident and talk about okay, how could we improve these things, or what have you already identified as things we could improve? But we use it also not just to look at each of those incidents that occur at the moment, but to identify long patterns over time. So for instance, if you happened to be at a talk just a few minutes ago, config management. Configuration management is a really easy way to cause outages on sites anywhere. There are themes there, and you can identify ways to actually prevent classes of failures once you've seen enough of them. When you have a process that encourages review and openness about failures, you can then come back to those incidents, go through them, identify the patterns, and build systems. Point to say, hey, if we had 3 people working on this for a few months, we would avoid, 20% of all of the outages we had this year. And that's pretty powerful, but you need the data and the system and the review to do it. One of the things we also like to do in this meeting is make sure we've asked why enough times, right? So there's this, I don't know, mnemonic or heuristic of asking why 5 times something happened, right? So why was I late for work today? Well, I got a speeding ticket on the way in. Why was I get a speeding ticket? Because I got up late. Why did I get up late? Because my alarm didn't go off. Why didn't your alarm go off? Well, because my phone's battery died. Why did your phone's battery die? Because my charger was broken. Well, that charger problem is the one to fix in that case, right? So you need to ask why to really, really understand it, and you need to prove it with data as much as possible. This gets back to that kind of forensics approach I mentioned, finding data to show, hey, this is what actually happened. Then 3 seconds later, this is the effect it had over here, and this is the effect it had over here, is super important, particularly when you're working with complex distributed systems. Complex distributed systems do not behave linearly or how you expect. Sometimes it's not often obvious, hey, this was the cause or this was a symptom. And really making sure you understand what happened through that, through instrumentation and logs, et cetera, is really important. And we use these reviews to make sure that those questions get asked and answered. But one of the things that's really important in this review is that the tone really, really matters. We want to make sure that people who attend do not feel, like they're in court, right? We don't want to make them feel cross-examined. We want it to be a safe and non-aggressive tone because the tone matters. We want it to be a positive experience. In fact, again, as part of getting people when they join the company used to this process, we invite them every time to come to a Sev review before you have to present, so you can just see the conversations. So you can just kind of get an idea so that when the time comes that you're presenting and it's your first time, you don't need to be too nervous, you don't need to be too worried. You've had your team help you prepare for it. And there are going to be a bunch of questions, but you'll get through it, right? And then your system will be better afterwards. And then there'll be lots of praise and excitement when those underlying issues are resolved and they never can occur again. Because after all, incident management fundamentally is a human process, right? It's humans fixing technical problems. It's humans who are going to bring it back. Very rarely will automation fix an incident for you. And incidents can hurt, right? Incidents can be pretty painful. They can be stressful in the moment. There can also be pride associated. Hey, if your system fails, you might feel bad about it. I certainly do. If I've made something and it crumbles when some kind of load is placed on it, I will internalize that and not be super happy about it. So it's really important that your process treat the people well, because the people are going to solve it, right? And to have empathy for the people involved in SEVs, to teach them, to set them up for success before the SEV happens, and then to help them through it. So that you can create that positive feedback loop that gets to that learning process, that gets to a prevention. Because ultimately, if you're having outages, that's okay. If you're having outages and not learning from them, that's a really big problem. Or if you're having outages and burning people out through it, that's a problem. One of the things that comes about through here is a strong sense of teamwork, right? feeling like you're not alone facing a problem. And again, like with our Sev tooling in particular, like it pulls people in, it draws them, it's inviting to them, it's very open, it's public, in a way that's still not like pointing fingers. You can also make it a little playful. One of the things we tend to do for major outages is we give them names, right? If you give something a name, it gives you an easy way to refer to it in discussion, but it also makes it maybe a little bit less scary or intimidating. These names can sometimes be playful. They can be like puns, or they can be jokes about like, hey, what was the actual root cause of the system or of the failure? They can vary a lot, but we find they help us a lot. So I want to give you some fake names for some failures, which sound so much fun. Like whenever I think of fake names for these, I like want to go cause an outage just to use the name, right? I have never done that. But like we would come up with names like brain freeze or zombie apocalypse or site not found, right? Things like that are like, oh wow, okay, this might indicate something of the underlying problem. So you can have a little bit of fun with it and you can talk about it later, which is again part of the learning, right? We talk about a lot of these Sevs by name in our early onboarding to like say, hey, there was a Sev, it was called this because of that, and don't worry, everything's okay, everything came back up. Because fundamentally it is about teamwork, right? Systems are big and complex, they're scary, and we need to really encourage people to be resilient to the failure. Until we can get our systems fully resilient, we need to make sure that like the process that we go through as the humans involved fixing the systems is also resilient. We need to also empower teams to move fast. Like we want to use learnings to make it to where you don't have to worry when you're pushing a change out. So very early days of companies when you're pushing configs out, if they go like site-wide relatively quickly or you're making a change to a database, if you don't have automation, then what you're really doing, if you're doing it right, is you're sitting there loading the site, making sure it works, reload, reload, reload. You make your change in a terminal and you keep reloading. Make sure everything's okay. And if it doesn't, you're like, oh crap, roll it back, roll back, roll back, right? Until you have automation in place that empowers engineers, that is a really terrible workflow. It's terrible both to go through it if you're being diligent, and it's really bad if you're not, because you're just landing something that may actually be causing problems. So we want these resilient systems to prevent the errors as much as possible, and our learning process and our feedback loop helps do that. And honestly, like nothing bonds a team together like surviving some kind of crisis. Like these can actually be, somewhat of a bonding experience. Like when I've been working on these things for a long time, and every time I come out on the other end of some kind of incident or Sev, I feel closer to the people I've worked with. Right? Because you have gone through something that was stressful, and you've survived, and you'll have a lot of work to do. But that's okay. In fact, one of the things I will tend to tell people is like the worst punishment for breaking something at Facebook isn't that you'll get fired, it's that you'll have to help fix it. Right? You're not going anywhere. You're going to help fix it and write it up, and we'll talk about it, and we'll all learn from it together, but you're not going to have to worry about getting fired. So kind of wrapping up, I'm going to give some unsolicited advice, at least based on kind of my experience here. You should make your incident management process follow your culture, because if there's too much of a mismatch, people won't do it, or it'll feel unnatural. But you should also be a little bit intentional about the culture you want to build around it. Like we're very intentional about having blamelessness be part of our incident management process. And you want to create feedback loops that help you continually improve both the process and, of course, the technology of failures, because you don't want to have repeat failures. You want to invest in tooling. Anything that like reduces the number of outages is super high leverage, or anything that even shaves a few minutes off of a very serious outage can be worth days, weeks, or even months of engineering time that goes into it. So it's really, really important to identify these and like understand like, hey, this is an extremely highly leveraged fix, even though it's not something flashy or fancy or some new feature. But you should start simple, right? Google Doc, Quip templates are really useful. I suggest having one. There's lots of good literature on exactly what those would look like, lots of good books on incident management or site reliability books that kind of cover through that. And then you should focus on the training and practice, because you do need people to be aware of the tools and systems before they encounter them the first time. And you should use smaller incidents to practice. Like our Sev 3s are very, very minor, definitely not user noticeable. They could just be something misbehaving, one or two machines acting oddly, but we still use it as a chance to learn and to kind of sharpen our claws so that we're ready for the bigger incidents. And you should also set some expectations about mindsets around incidents and around what you expect from response, what good response looks like. This may vary depending upon your business. If your business is just putting cat pictures on the internet, maybe you can handle 5 or 10 minutes of outage, but if your business is like landing airplanes or medical equipment, there's a slightly different expectation there. So that should be reflected in the process. So before we finish up, I'm going to give kind of a sanitized real outage from a few years ago, just to kind of talk about what we do and how it goes through. So you could imagine many years ago, there was a boot camper at Facebook, like third or fourth week at the company, working on a task. That's how Facebook starts. You get a bunch of tasks that teach you all sorts of different things in different systems because you haven't picked your team yet. This is just kind of exposing you to our tools. This boot camper is reading through the task. It says, okay, run this command to create a test set of data, run this command, this command, this command. Boot camper's just doing it exactly right, and then suddenly the tool stops working. It's like, oh, something's not working here. Enter, 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 it doesn't work. Maybe it's my server, whatever. I'm going to go to dinner. That's what you do. Meanwhile, while this boot camper is at dinner, many of us are going like, why are so many things not working? There was actually a fairly large internal outage caused by this. What happened is they just tripped over a bug. There was just a bug that had been there for years that something about the nature of the test data they had used for their test feature was actually tripping up production instances. So of course there's this big scramble while boot camper's off eating dinner, everything's going fine. We figure out exactly what happened and we revert it, and like the first thing we do once we realize exactly what the cause was, we go tell the boot camper, stop working on this, don't do this, don't touch this task anymore. But the boot camper wasn't blamed, right? The boot camper was not made feel bad. At no point we were like, oh, this boot camper, that's what boot campers do, right? And we weren't even like, oh, this person who made this task, what a clown, what were they thinking? Right? Nothing in this task, nothing in what the boot camper did was predictable. This is one of those black swan things. Like, you can go back in retrospect and look at it and understand it. And in fact, the line of code that had a bug, the person who wrote that, again, they were not in trouble, but we learned from it. We actually realized, hey, it's a C++ issue. Let's fix our compiler, which we did. We learned a lot of things from this Sev. But most importantly, I think, is like this boot camper is still at Facebook, doing great things to this day. This was many years ago. There was no stigma attached to this Sev. We got a lot of learning from it. In fact, to this point, it's almost meta-learning because I talk about this Sev, again, in boot camp. When we're telling people it'll be okay. What's the worst thing you can do, right? Well, here's an example, and everything worked out okay. So just some kind of key takeaways. Map these processes and ideas to whatever fits your companies. But do build a system that focuses on learning and transparency, because otherwise you'll just kind of have the same issues, right? You'll have the same failures, and you won't really get to the root causes of them. Build tooling when necessary. I wouldn't suggest like going and building an elaborate thing like we have until you really need it. But once you do, make sure it's there and solves problems. But use simple tools and process before then. You don't necessarily have to invent brand new things either. There are some tools out there. There's lots of good processes. You can borrow the parts that fit and build a culture around it. And finally, like, celebrate the outages. Like, you got through them. You survived. It will be okay. Even at the worst, darkest moment of a really bad outage of some kind, like, it will get fixed. Maybe it'll be super fast. Maybe it'll take longer. Maybe there'll be a bunch of big cleanup. But at some point, you will look back, and everything will be fine, and you'll be like, wow, it's over. Yes, awesome. That's the point you should get to, and be okay with that, and realize these will be the things that happen, especially for us, things we focus on as production engineers or SREs or software engineers or sysadmins. Like, these are the things like we get pulled into. So like, celebrate these opportunities for learning, and like, don't count the number of outages in particular. Like, that will have an awesomely negative feedback loop on your systems. All right, I think we have a few minutes for questions. Thank you.
Hi, I'm Connie Lynn Villani. I'm the Director of Incident Management at Fastly. And one of the things I wanted to ask you is, when you talk about doing blameless review, one of the things I found is that really good engineers who have caused outages to happen have the most tendency to blame themselves and to turn that back on themselves. And what are some of your strategies to keep that from happening?
It's sometimes hard to know the internal state of an engineer. We would rely in a lot of cases on the context around the incident review to not be blameful, and to make sure that like the people who work with that engineer to identify that. My advice to that kind of engineer is, like, it doesn't feel good when something bad happens, especially like if it was your fault, right? Fundamentally, like, you didn't foresee something or you wrote a bug, but it's okay, right? It is okay. We're humans. We'll make mistakes. I think the only time where I would be negative about something like that and like have a tough conversation would be like if someone were trying to cover up a problem, like sweep it under the rug or something like that. So like encouraging like, hey, no, we're open about this. It's okay. Like this is not like a negative repercussion. In fact, there's a lot of positive opportunity for like making sure this doesn't happen again from learning. If this person's like tenured or a tech lead, like they should then take that as a learning opportunity and like see the humility in the moment of like, boy, this sucked. How am I going to make sure it never happens to me? And then make sure someone who's just joining my team from industry also doesn't have this problem, right? How am I going to pay it forward rather than like looking back on it as like this painful and embarrassing moment?
So in one of your slides, there was a screenshot of, I believe that was Sev Manager. I noticed there's a field called visibility. What is that for, and how do you balance this with like knowledge sharing and I guess reviewing and those process?
So for we use that very rarely. It's really when there's say like an open source CVE or something like that. Like same reason like some vulnerabilities aren't disclosed publicly while the vendors are patching them. We just want to make sure that we get those fixes in place before we like open it wide up, right? Before everyone can see it. What we'll sometimes do is put the details of the actual problem in one Sev where those details are hidden, and then have a more public one with like, hey, you need to rebuild your binaries for X, Y, or Z, such as an OpenSSL exploit, right? Those kinds of things you really don't want to publicize. Sometimes because you might have like extra knowledge, you might have identified it. It might not even have a CVE yet, and so you don't want to leak that information just anywhere that someone might not even understand it was embargoed.
Thanks.
Cool.
Okay. Thank you,
Oh.
Jim.
Sorry, quick question. Are you familiar with any other tools that are similar to the ones that you built in-house? Right now, my company uses a mix of PagerDuty, Slack, Jira, all of that, Zoom video, and everything is all over the place. I'm not sure or anyone else knows about anything else. Let us know.
I do not. The one thing I would say is I've heard good things about PagerDuty. I don't know how far it extends into here because honestly, I've been working at Facebook for a long time, and before that I was at another private company that built a lot of stuff on our own. I know there's some stuff out there. I do know PagerDuty has a full incident management process that's based on, I think, ICS, right? There's like the National Incident Command System that's invented like historic reasons. In fact, I think there was a talk on some of this earlier in the week. I think some of the tooling is coupled with the process, so I don't know how generic that tooling is, but I mean, like if you're just starting out, like I would just take something that exists and modify that rather than have to like cope with mailing lists and just like files in a directory.
Last call for questions. Okay, great.
Thank you.